Hi everybody, today we're going to talk about solving ratio problems. So we are on lesson 1-5, so module 1, lesson 5. Let's jump in. We've talked about how to find equivalent ratios using tables and graphs. So we're going to continue that now with looking at problems and finding equivalent ratios and finding missing values. So suppose 3 out of 5 randomly selected students at a certain school play sports. There are 525 students at the school. We're going to move through the slides to create a bar diagram to predict how many of the students play sports. So the first thing when we're creating a bar diagram is to obviously draw a bar, right? That's kind of helpful. So we're going to draw a bar. Then we go back to our original ratio, 3 out of 5. So that's a fraction, right? So we can show 3 out of 5 using our bar by first dividing it into 5 sections. Then we shade in 3, right? These 3 represent the students that play sports. These are the students that do not play sports, okay? So we're given the fraction 3 out of 5. We're using that information in our bar here. Now, we know that there's a total of 525 students. We're told that in this situation right here. So the entire bar represents 525 students. Now, we need to figure out how many students belong in each section. Well, if we have 525 students and we have a bar with 5 sections, we're going to divide by 5, right? 525 divided by 5. Each section is then worth 105. So we'll label 105 in each of our sections. Then we can finally figure out that the 3 sections labeled play sports, right? 105, 105, 105, where 3 times 105 would be 315. Now, that would be the answer to our question, right? How many of the students play sports? So we multiply by the number that is shaded, 3, times what's in each box, 105, to get our answer of 315. So when we're thinking about ratios, we can think about it as a fraction, right? We've talked about that a little bit. And you can represent fractions using bars and then breaking it up into the total amount of pieces and then finding how many are selected, right? That 3 out of the 5. Okay. So we're going to practice this. As soon as it loads, there we go. So we're going to use a bar diagram to solve ratio problems. Oops, I'm going to fix this quick here. And it says 2 out of 3. Okay, let's start by making some information, right? 2 out of 3 randomly selected students in Mrs. Mason's class at Heritage Middle School prefer cats, a household pet, than any other pet. Now, if we have a total of 750 students, how many students can be expected to prefer cats as a household pet? So we're going to do the same kind of thing here. We're going to use that 2 out of 3, right? The fraction, 2 out of 3, okay? And we are going to use the total of 750 and find what's missing here, okay? So let's go ahead and give it a try. We're going to create a bar diagram once again, right? So always first step, draw a bar. Makes sense when we're making bar diagrams. Then we're going to use that fraction, right? 2 out of 3. So here's 3 sections, right? Because that's the total amount of sections I need to have. This is how many we need to shade, that 2, right? 2 out of 3. So this is the amount that prefer cats. These do not prefer cats. So we want to make sure to label our bar so we know what they mean. Then we're going to take that 750. That's the total amount of students. The total amount of students extends across the entire bar. Then we divide 750 by 1, 2, 3 sections, right? So each section then would be worth 250 because 750 divided by 3 equals 250. we can then find the answer to our question. Okay. So how many students prefer cats? Well, we can just put these two together. 2 times 250 would be 500. So we could assume that 500 students would prefer cats, right? So we would put 500 students prefer cats. Now, how can you use ratio reasoning to check your solution? Well, if we know, pull up marker here, we had 2 out of 3, right? And we knew that 750 students total belonged in our middle school. And we said 500, right? Are these ratios equal? So if I divide 500 by 2 and 750 by 3, do I end up with the same number? So if I were to work this way, 750 divided by 3, is that 250? Should be. And is this 250? It should be. Okay. So that's how we can check it. We can set it up like one of the first ways that we have done ratio reasoning to make sure that our answer is correct and makes sense. All right, let's try another one. So remember, whenever we're doing this, we have several steps. First thing is to separate your bar, draw your bar, right? Second step would be then to break it into the total amount of sections, shade in the number of sections selected, label all your pieces, and then you can solve, okay? So let's go ahead and try this. A survey of Mrs. Thompson's class shows that out of 30 students, 17 of them have a dog. So let's go ahead and draw our, draw our bar. Let me bring back my board. There we go. Hit the wrong button. Happens from time to time. So remember, the first thing that we do is we draw a bar. Here is my bar. I know it's super straight. Such a great artist I am. And we know, let's make my bar a little bit bigger. Okay. So the first thing that we're going to do here is now draw 30 sections. Yes, that seems like a lot, but that's what we need to do here. So we're going to do some movie magic. I'll pause you here and come back with 30 sections. All right, so we've drawn our bar with 30 little boxes. I then shade in 17 of those to show 17 out of 30. Now, the next step is remember to label our bar. So this entire bar would represent 300 students. Okay. Now, the next step that we need to take is to take that total amount, right, 300, and divide by the number of little boxes that we have total in our bar. Okay, so 300 divided by 30 would be then 10, right? So each box is worth 10. So what I could do is I would go in and I would label all my little boxes. That's going to take me a while, okay? So I'm just going to do some, just so that we get the idea of it. Each of these is worth 10, right? And we know that 17 of them are shaded. So let's multiply 10 times 17 to get our answer. So in this case, when we multiply 10 by 17, we would get 170. So we would say that 170 students would be expected to have a dog in this situation. Okay, so remember our steps. Draw the bar, break into the total number of sections, shade in the part, label the total amount in the new problem, and then divide and multiply. Okay, so lots of steps to do here. But when you do those, you'll get the answer every time. All right, so let's move on. We're using a bar diagram still, so using our steps. So during their family vacation, Marcus took 18 photos on his cell phone. The ratio of the number of photos Marcus took to the number of photos his sister Maribel took is 3 to 4. So how many photos did Maribel take? So we also need to think, is the number of photos Maribel took less than, greater than, or equal to 18? And how do we know? So that's our question to think about. So the first step for this, once again, draw a bar, right? Always step one, draw a bar. Okay? The ratio of the number of photos Marcus took to the number Maribel took is 3 to 4. So the bar is divided equally into 4 equal sections, right? Start with that 1, 2, 3, and 4. Then we say, okay, Marcus took 3, right? Maribel was 4. Okay. We need to figure out how many photos Marcus took. So we're going to put an 18 up here. 18 goes there. Oopsies. I actually have to enter the answer, I guess. So, 18. Check. There we go. So, because we were told that information here, Marcus took 18. Then we're going to divide the total number of photos Marcus took by 3 to determine the value of each section. So 18 divided by 1, 2, 3, right? So each of these would then be worth 6. Put them in there. And this final section would also be worth the same amount, right? Each of those would be worth the same amount because the sections are all the same size, right? We divide it. So we check, we get 6 in each section. So then, how many total did Maribel take? Well, if Maribel took 4 sections, right, we would do 6 times 4, and her answer would then be 24. So this is one of those situations where we're kind of missing the whole number here, and we know the part. So we're working a little bit differently, but the process is still the same for drawing a bar. Okay? So we know that it's a total of 24 photos that Maribel took. Now, how does the bar diagram indicate how many more photos Maribel took than Marcus? When we look, we see one extra section. So we know that she took more, right? Because we have a missing section here. And it would be that extra amount, right? So that would be that additional 6 that Maribel took. All right, we are going to move on to the next resource here. So let's go ahead and try this on our own. So we're going to be given another situation. Elisa's mom teaches at a preschool. There is 1 teacher for every 6 students. There are a total of 13 teachers. So once again, we know the part, okay? So start, as always, by drawing a bar. Oops. Come on. Draw our bar. Okay? 1 teacher for every 6 students. So we're going to start by dividing it into 6. 1, 2, 3, 4, 5, 6. Okay. We know 1 section here. Okay. And that would be worth, this is the teachers, right? So this is that 13. Well, if this bar is worth 13, then we would do all the bars, or all the sections being 13. So we would do 6 times 13. Okay, so then we would multiply 13 times 6, 6 times 3, 18, 6 times 1 is 6, plus 1 is 7. So when we entered this, or I have to get rid of that, we should have 78 students when we solve that problem. So remember, draw the bar, break it into the total amount of sections, right? Talk about our steps. Step 1, draw a bar. 2, break it into total sections. Step 3, shade in which is that 1, okay? Fill in what we know is our next step. So if we know that there's 13 in that part, right? This 13, we're going to put that in one box, but then every box is also worth 13. So we fill in 13 for all the boxes. And in the end, we just simply multiply. Okay? All right, excellent. So let's move along to our next. Now, another way to do this, right? We've talked about bar diagrams before, is also to use double number lines. And we've used double number lines before in showing equivalent ratios. So here we go. Once again, coming back to that equivalent ratios. It says the manager of a small hotel determines that it takes 30 loads of laundry to clean the towels and sheets of the hotel rooms each day. A large bottle of laundry detergent contains 150 ounces, and the label indicates that the contents of the bottle can clean 75 loads. How many ounces of detergent are needed to clean the hotel's towels and sheets each day? So we're going to use a double number line in this case. We want to move forward. There we go. So the first thing we do is to draw and label a double number line, right? Loads and detergent ounces, okay, would be the labels for our two number lines. There we go. It was there somewhere, okay? And then we can go ahead and label each of them. Our original ratio was 75 to 150, okay? Because that's what it was told. It makes 75 loads with 150 ounces of detergent, okay? Then we can say, all right, what can I divide these by? Well, we're going to divide it into 5 sections, okay? So that we can get to that 30. So I break it into 5 sections, 1, 2, 3, 4. There's our 5th here. So 75 divided by 5 is 15. Oopsies. I get out of here. 75 goes divided by 5 is 15. And we also do the same thing with 150, dividing it by 5. Okay? So when you do that, you would know then that that would be 30. Then we can start filling it in. 15, 30, 45, 60, 30, 60, 90, 120, 150. Then we look, all right, if we knew that 30 was the magic number here, right? It takes 30 ounces of detergent or 60 ounces of detergent, sorry, then we would know then the value would, if we needed to do 30 loads, we would get 60 ounces of detergent, right? So we would plug in our 60 here because that's what matches up with our missing value, okay? So 30 loads, 60 ounces of detergent. There we go. Now, another way you could do this is just to simply use equivalent ratios, okay? So we can write and solve our ratios simply like this, right? 30 loads of laundry, D detergent, right? We don't know how many ounces yet. Then we set up our other ratios, 75 and 150. Oops, come on, I know you're there somewhere. Then what we do is we say, because 75 divided by 2.5 is 30, we can divide 150 by 2.5 to find the value of D. Now, if this doesn't make any sense and you don't like using decimals, that's okay. There's another way to do this. And I'll give you an example in just a minute, okay? I'm going to give you an easier way to do this, I think. So, if you were in class yesterday and you were working on your warm-ups, I gave you a way to find missing values in fractions. And I said, you can take what's on the diagonal and multiply them together and then divide by the other value. So I could take 30 times 150, 150 times 30, okay? Here's what I'm going to do. I'm just going to get rid of these two zeros. 0, 0, 3 times 15 is 4,500, right? Then I can divide by 75, okay? So if you were to do that, it makes things a little bit simpler, okay? And you would still come up with that same value of 60, right? So 75 times 6, let's double check, 6 times 5 is 30, 6 times 7 is 42, plus 3 is 45. Oh, perfect. So if we take 4,500, divide by 75, we know that it goes in 6 times here, right? 0, 0, 60. We're still able to find the same value. And it's a little bit simpler than just like guessing, okay? Guessing that 2.5, right? 75 divided by 2.5 is 30. A little bit easier. Multiply on the diagonal, then divide by what's left over. Easier way to find the answer than how they show you here. So this is just another tool for your toolkit. And that works on any fractions where you're trying to find the missing value. Okay. Multiply on the diagonal, divide by what's left over. Now, let's take a look at another double number line. As soon as it loads. Okay, so the manager of a grocery store determines that an average of 480 jars of peanut butter are sold each week. 2 cases of peanut butter contain 96 jars. How many cases of peanut butter should the manager order each week? So we're going to make another double number line here to solve our ratio. Okay, so step 1, draw and label. The top line represents the number of cases. The bottom line represents the number of jars, if it would load. Okay, we're just going to skip it. It'll let us. Okay, so there we go. Sometimes it gets a little stuck, and that's okay. Then we're going to label what we know, okay? We know that we have 480, okay? And we have 2 here. So we need to figure out the missing values here. The ratio of jars 2 to 96 is labeled, and we are going to increase the number of jars up to 480. So we're just going to keep going 96 plus 96 plus 96 plus 96 plus 96 until we hit that 480. We can then see that this top line is going to increase by 2, right? So this should be 2, 4, 6, 8, 10. Now, when we get to 480, okay, we would know that the total number of cases would be 10. So if we enter our value 10, we should be correct. Okay, so they gave us the original ratio here. We needed to work up to 480 to get to then 10. Now, once again, you can use equivalent ratios for this. The number of cases we said was 2 here. I'm just going to use this 2. And the total number of jars was 480. Okay. Now, if you remember what I said previously, we can multiply by these 2 and then divide by the other. So 480 times 2. 2 times 0 is 0. 2 times 8 is 16. 2 times 4 is 8 plus 1 is 9. 96 or 960. 960 divided by 96. Oh, that's pretty easy, right? Our answer here is 10. Okay, once again, multiply on the diagonal, divide by what's left over. Super fast answer right there. That's a quick way to do it. Okay, so there's 2 different ways to find those missing values. All right, so when we find this problem here, it says 5 out of 12 students at Perry Middle School share a locker with another student. There are 456 students that attend Perry Middle School. So how many students are expected? All right, so taking a look at this example, we see here that 5 out of 12 students at Perry Middle School share a locker with another student. There are a total of 456 students that attend Perry Middle School. How many students are expected to share a locker? Now, in this case, using a double number line really won't help us, okay? Because we don't want to draw lines all the way out to 456. It seems like a lot of multiples of 12. So in this case, this is where we're going to use that equivalent ratios. Now remember what we said. We're going to multiply 456 by 5, and then we'll divide by 12. Okay? So let's go ahead and do this. 456 divided by 5, or multiplied by 5, I'm sorry, is 30. 5 times 5 is 25, 28, 22. So now we have 2,280. Like I said, we divide by this 12. 12 goes into 22 one time, and we subtract, and we get a 10. 12 goes into 108 9 times, right? 12 times 9, 18, 9, yep, 108, 19, or so there we go, 9 times, and that is 108, and then we have a 0 and a 0. So our answer here would then be 190. So let's double check our answer here. 190. Ooh, whoops, it's because I have a comma in there. Delete that. There we go, 190 students. So sometimes you need to use an equivalent ratio instead of a double number line because it's not practical to sit there and draw out so many multiples, right? When you're dealing with larger numbers. Okay. So that's it for today's lesson. As always, please remember to do your assignment on the McGraw-Hill site. And if you have any questions, please let me know, and I will be happy to help you. Have a great day.